How does a 3-speed constant mesh gearbox work? The 3-speed constant mesh gearbox is a manual transmission system designed with 3 forward gears and 1 reverse gear. In this type of gearbox, all the gears on the countershaft and main shaft are in constant engagement, eliminating the need to align them during operation. The transmission uses dog clutches to engage or disengage gears, instead of sliding the actual gears as in older sliding mesh gearboxes. Double declutching is required in older systems without synchronizers to match the speed of the gears for a smooth transition. This type of gearbox is widely used in older vehicles and offers reliable performance when operated correctly. When the gearbox is in neutral, the input power from the engine flows through the clutch shaft to the countershaft, causing the gears on the countershaft to rotate. However, since the dog clutches on the main shaft are disengaged, no power is transmitted to the wheels. The constant engagement of the gears ensures that they are always synchronized and ready for operation. Neutral is essential for idling the vehicle or preparing to engage a gear. In this state, the engine continues to run, but the vehicle remains stationary because no torque is transferred to the wheels. Engaging the first gear involves sliding the dog clutch on the splined main shaft to connect it with the low gear. This setup achieves a high torque output at a low speed, which is essential for starting the vehicle or climbing steep gradients. For older constant mesh gearboxes without synchronizers, double declutching is crucial. The driver first presses the clutch pedal to disengage the clutch, moves the gear lever to neutral, releases the clutch to let the gears synchronize, presses the clutch again, and finally shifts into first gear. This process ensures smooth gear engagement without grinding. Engaging second gear involves sliding the dog clutch to connect the second gear on the main shaft to the corresponding gear on the countershaft. The second gear offers a balance between torque and speed, making it suitable for accelerating or driving at moderate speeds. Similar to the first gear, double declutching is required in systems without synchronizers. The driver disengages the clutch, shifts to neutral, releases the clutch to synchronize the gear speeds, presses the clutch again, and then shifts into second gear. This process minimizes wear on the gearbox components and ensures a smooth driving experience. In top gear, the dog clutch is used to directly connect the clutch shaft to the main shaft, bypassing the countershaft. This direct drive eliminates any gear reduction, allowing the engine's full power to be transmitted to the wheels. Top gear provides the highest speed with the lowest torque, making it ideal for highway cruising and fuel efficiency. In some constant mesh gearboxes, top gear may involve engaging the smallest gear on the countershaft for high-speed driving. The constant mesh design ensures a smooth and efficient transition to top gear, reducing noise and improving drivability. Engaging reverse gear introduces an idler gear into the power flow. The idler gear reverses the rotation direction between the lay shaft and the main shaft, enabling the vehicle to move backward. When the driver selects reverse gear, the idler gear bridges the reverse gear on the lay shaft and the gear on the main shaft. Unlike forward gears, double declutching is not usually required for reverse since the idler gear does not require precise synchronization. However, the reverse gear operates at low speed with high torque, ensuring controlled movement during reversing. Advantages of a 3-speed constant mesh gearbox. 1. Smoother gear shifting. The constant engagement of gears ensures smoother gear shifting compared to a sliding mesh gearbox. Dog clutches enable easy engagement, reducing the effort and noise during gear changes. 2. Reduced wear and noise. Since the gears are always in mesh, there is minimal gear tooth collision, reducing wear and tear. This design also ensures quieter operation, enhancing the gearbox's durability. 3. Easy of operation. The use of dog clutches makes the gearbox easier to operate, requiring less skill than sliding mesh systems. This provides a more user-friendly driving experience. 4. High reliability. The robust design ensures long-lasting performance, making it reliable for heavy-duty applications like tractors and trucks. The gears, being constantly engaged, are less prone to damage. 5. Improved power transmission. The constant engagement of gears reduces energy losses during shifting, making the gearbox more efficient compared to sliding mesh systems. Disadvantages of a 3-speed constant mesh gearbox. 1. Requires skillful operation. Although easier than a sliding mesh system, it still demands driver skill to synchronize the clutch and throttle, especially during quick gear changes. 2. Noisy operation. The constant engagement of gears and dog clutches generates noise, which, while less than a sliding mesh system, can still be significant. 3. Higher manufacturing costs. The inclusion of dog clutches and precise gear design increases production costs compared to simpler systems like the sliding mesh gearbox. 4. Frictional losses. The constant engagement leads to some frictional losses, reducing efficiency compared to modern synchromesh gearboxes. 5. Limited gear ratios. The 3-speed configuration offers fewer options for speed and torque, limiting the gearbox's versatility in varied driving conditions. 6. Maintenance requirements. The dog clutches experience wear from repeated engagement, requiring regular maintenance to prevent operational issues.